Hello, everyone. How's Vegas treating you guys? Awesome. Very timid, but. My name is Mahe Ko, and I'm here with my good friend and colleague Morgan Thomas from the Amazon Simple Email Service team. Welcome to ARC342. We're going to talk about building email applications and infrastructures with AWS. So for the next hour or so, we'll discuss some of the most common pain points that businesses experience when building email architectures with AWS. After that, we'll discuss how AWS can solve some of those problems for businesses. And finally, Morgan will be presenting a couple of practical examples that will demonstrate how easily you can build email applications with AWS. So let's begin. Around 10 to 15 years ago, a lot of people claimed that email was dead. And this was caused by the fact that there were a lot of spam going through the internet. And there was not a lot of good mechanisms for preventing them. But in 2015, we know that email is not dead. With every second that passes, the internet sends and receives more than 2 million emails. And if you're a fast-moving business, then you know that you write and read hundreds of emails a day just to get stuff done. You have applications that are sending and receiving millions of emails an hour so you can communicate with your customers. But we take email for granted. There's actually a lot of stuff going on in the background that keeps email alive. And it's this stuff in the background that helps email continue to be the de facto standard communication medium for businesses. A typical 1,000-user organization will spend upwards of $1.8 million a year just on managing spam. Now note that this figure does not include the cost for making sure that your emails are delivered and opened by your customers. It does not include the cost for making sure that you have enough hardware to be able to handle your next big marketing push. So why are businesses spending so much money on email? Well, there's a lot of different kinds of responsibilities and roles that are involved in maintaining your email infrastructure. So to guide us in our analysis of why email costs so much, we're going to take a look at some of the responsibilities and how AWS helps you solve those problems. The first kind of responsibility that we'll look at is the postmaster role. Postmasters are responsible for figuring out whether or not a message should be accepted and placed into the inbox, or quarantined and placed into the spam folder, or simply dropped on the floor. Sometimes postmasters are engineers that are configuring their postfix servers. Bigger businesses have teams of people that maintain relationships with senders and implement custom filters. For example, your postmaster might maintain your sender reputation system. When you click on the Report Spam button on your email client, what you're doing is you're letting your postmaster know that a spam message has gone through the existing spam filters. So then the postmaster can examine this message and look for certain patterns that it can use to prevent further abuse. Now, this pattern could be the sender's IP address, domain name, certain keywords in the content, virus signatures in the attachments. Now, these patterns are aggregated over time by the postmaster to produce a sender reputation metric. And this sender reputation metric is then used to decide whether or not a future message should be accepted or rejected. So there's this sort of feedback loop where you receive a message, you determine whether or not it's spam, and you use that information to improve your own anti-spam system. On the flip side of postmasters are deliverability managers. Deliverability managers are responsible for making sure that your emails, the emails that you send, are delivered to the widest possible audience. Now, this involves maintaining a good reputation as a high-quality sender. You don't want your newsletters and legal notices to end up in the spam folder because someone happened to click on the Report Spam button last month. So deliverability managers work with postmasters to make sure that their emails comply with the various kinds of security standards that the postmaster might enforce on. One example of what your deliverability manager might do is to maintain your SPF records. Sender Policy Framework is a framework that allows senders to advertise which IP addresses are authorized to send on behalf of your organization. So you list the IP addresses that are authorized, and the receiver can then look up this information. And when they receive an email from your organization, they can look up whether or not the sender was an authorized sender. What this does is that it helps receivers differentiate your emails from phishing attacks, or otherwise known as spam. Another example of what your deliverability manager might do is maintain your DKIM signatures. DKIM is a similar mechanism as SPF, and it serves a similar purpose. However, it does so in a more robust way using cryptography. Domain key identification works like this. The sender can generate a private and public key pair, and they can start signing their messages with the private key, and then advertise their public key. So then the receiver can look up this information and validate whether or not a given message was actually sent by the purported sender. Again, this is a useful mechanism that allows you to differentiate your mail from spam. We've all heard the statistic. 90% of all mail in the internet is spam. So it's important to make sure that you differentiate your emails from spam. So deliverability managers are sort of like SEO managers for email. Except you're not really optimizing for search engines anymore. You're optimizing for email clients. So you can make an analogy here again. If postmasters are sort of the human equivalents of the report spam button, deliverability managers are sort of the human equivalents of the this is not spam button. They're constantly trying to convince other postmasters that their emails are not spam. Also looking after your email infrastructure are system administrators and engineers. Now, these are the people that install firewall devices and virus scanners. They read through hundreds of pages of operator manuals to try and figure out how to configure these devices. They maintain your mailbox servers and make sure that they're configured and scaled up correctly so that they can handle all the different kinds of consumer devices you have available. They also make sure that you have enough hardware to handle your next big marketing push. They maintain and build applications for sending and receiving email, for customer support, and campaign management. And campaign management is actually a very interesting one because there's a lot of stuff going on for managing campaign. For example, you want to be able to track which one of your customers clicked the spam button so you can stop annoying your customers. You want to be able to track bounces so you can be notified when your customer changes their email address. You want to be able to track opens and clicks so you can see how your customers are responding to your emails. You want to be able to test different kinds of emails to see what kind of messaging resonates the most with your customers. All of this is achieved by your campaign management system, whether you purchase a service or build your own. When we put this all together, what we have is a complex landscape that every business must be able to navigate in order to communicate with their customers. And maintaining your position as a high-quality sender and receiver is crucial for making sure that your email infrastructure stays healthy. And this is what we believe to be the root cause of why email costs so much. So how can AWS help? So this is what your classic email architecture looks like. Between the internet and your consumer devices, you have a whole variety of things that come into play. You have your firewall devices that are responsible for enforcing your sender reputation metrics and deciding when to accept or reject a given message. You have your content scanners that are responsible for looking for virus signatures and attachments and otherwise suspicious behaviors. You have your mailbox servers that need to be scaled up and configured to handle all the different kinds of consumer devices available today. And then you have your email applications that send and receive email for customer support and marketing. As businesses grow, what we notice is that businesses need to be able to horizontally scale their email architectures. Your business is growing, so your customer base is growing, so your communication needs are growing. So you need your email architecture to grow alongside with your business. Unfortunately, the way many businesses were solving this problem was by buying new hardware, negotiating long-term service contracts with third-party vendors. And a lot of these specialized hardware devices are not easy to work with. So sometimes you need to hire engineers that are specialized for these devices. So this quickly becomes an expensive operation for many businesses. So this was not an acceptable situation in the eyes of AWS. So 4 years ago, almost 5 years ago, in 2011, the Amazon Web Services launched a simple email service, which allowed businesses to send all kinds of emails, from marketing to travel documents to tax documents, legal notices. We took on the duty of your deliverability manager. And we made it easy for you guys to comply with various security standards like SPF. We made it easy for you to manage your DKIM keys and make sure that all your emails are signed with DKIM. We allowed you to scale up your marketing campaigns without having to scale up your infrastructure. And we provided tools to make sure that you can track your bounces and complaints. But what about receiving mail? While Amazon SES was able to alleviate the pressure that marketers put on email architectures, many businesses have had to maintain their own architectures for email because they couldn't receive mail. Maybe you have a customer support application that tracks your correspondence with your customers. Or maybe you want to use email to transfer ebooks into your Kindle device. Or maybe you want a simple mailbox that you can access with your mobile device. Well, 2 weeks ago, the Simple Email Service team launched a new feature called Receiving Mail. By launching Receiving Mail with Amazon SES, we're now taking on the duty of your postmaster. So we made it easy for you guys to classify spam as spam and classify virus as virus. We made it easy for you to validate SPF and DKIM. By introducing Receiving Mail with Amazon SES, Amazon Web Services is now closing the loop on email. We're now able to take your architecture that used to look like this and turn it into this. Beyond just simplicity, we provided many integration points with other AWS services so you can leverage AWS's building blocks to build and manage your email architectures. We integrated with Amazon S3, an AWS key management service, so you can encrypt your inbound messages and store them securely. We integrated with Amazon SNS, so you can consume your inbound email events asynchronously. We even integrated with AWS Lambda, so you can manage your email applications without having to manage any kind of hardware. And this is perhaps my favorite part of this new feature. By using synchronous invocations, you can control whether or not you want to accept or reject a given message. And once you've decided to accept the message, you can use asynchronous invocations to further process your emails. This allows for so many different use cases. And that's why this is my favorite part of this new feature. And we also integrated with Amazon Workmail, Amazon's mailbox service offering. Now, if you're an early adopter and you already use Amazon Workmail, you might be pleased to find that you already have an inbound email rule configured automatically for you. Now, with this new feature, what you can do is that you can extend your rule set to provide programmatic access to inbound email. We implemented a rule engine analogous to the rule engines that you see in a lot of email clients. You can set up a list of recipients that you want to receive for, and you can set up a list of actions that you want to trigger for each of those recipients. We also implemented a filtering system that allows you to control the source of traffic coming into your email architecture. Amazon SES works with postmasters and deliverability managers from all over the world to make sure that our anti-spam techniques stay up to date. However, spam is not really a universal constant. Every person in here has a different definition of spam. And naturally, every business has different security policies on email. So we provided the tools necessary for you to customize your email architecture based on your individual business needs. These new tools from Amazon SES allow postmasters, deliverability managers, system administrators, and engineers to do their jobs more effectively so that you can focus more of your resources on your business problems. We made email accessible to those who haven't read ARC342 on My Messages or ARC342 on SMTP. We've heard numerous stories about businesses who successfully migrated their entire infrastructure to AWS, but have had to maintain their on-premise email architectures for email. With this new feature, Amazon Web Services is taking yet another step towards helping you operate your business without having to worry about your infrastructure needs. So before I pass the mic to Morgan, I'd like to conclude with this blog article, which reads, "I thought I knew how to validate an email address until I read the RFC." And I think this accurately illustrates how we feel about email. It looks simple. It seems easy. But once you start looking into the specifications and all the details, it's incredibly complex. And the RFCs are not easy to read. They are extremely confusing. Did you know that a double quote is allowed in an email address? There's a lot of weird facts about that. So we've read RFC 822 and RFC 5321 so that you don't have to. We have the specs on our desks so that you can focus on your business and reinventing. So with that in mind, I'd like to introduce Morgan, who will be presenting a couple of practical examples that will demonstrate how easily you can build responsive communication platforms with AWS. So please give Morgan a warm welcome.
Thanks, Mahe. Next, I'm going to add to Mahe's overview and show you how you can leverage the new features of SES with AWS to help solve some common solutions or common problems that businesses of all sizes may experience relating to email. So in addition to SES, we'll use Lambda and a handful of other AWS services. So there are now a handful of common use cases that can easily be solved with the new features of SES. You could automatically create support tickets from incoming customer requests. This saves your help desk the trouble of having to do so manually. You could take it a step further and implement an email autoresponder so that your customers know that you've received their request. You could create an email archival solution with SES, saving copies of messages to an internal email list, for example. Or you could receive files via email and perform some automated processing on them, such as image conversion. So today, I'm going to focus on demoing a few solutions I think you'll find most useful. The first of which is anonymous email communication. So what does this mean? Well, the following is a problem we've seen AWS customers having, and I'd imagine that some of you have faced similar problems. Let's say that your company provides a platform allowing customers to sell things, such as Amazon's marketplace, which allows third-party sellers to list things on the Amazon website. Now, as you might imagine, these transactions oftentimes require communication between the buyer and the seller, whether it's the buyer asking a question about the product or the seller asking for feedback about a recent transaction. It doesn't matter. The most convenient method for this type of communication today is email. However, there's a small problem that you may encounter, which is that both the buyer and the seller in this scenario are your company's customers. And similar to Amazon's retail business, you likely want to protect your customers' information at all costs. This means you cannot simply hand over the email address of the seller to the buyer, or vice versa. Each customer's email address must remain private. So the way that this problem is commonly solved is by putting some sort of email proxy between the two customers. This hides each customer's email address from one another. Now, this is not a super hard solution to implement. However, it just got much easier with the new features of SES that Mahe introduced. So let me show you what this experience looks like from a customer perspective. Let's say I purchased a selfie toaster from the Amazon website. And people who may know me know that this is not so unusual, but let's say I have a question about the image quality of my toast face. So I can contact the seller through the website, and the seller will receive my question in his inbox. And it'll be from my name. You'll see Morgan Thomas. However, my email address is obfuscated. In fact, it's replaced with the order ID at some subdomain of Amazon.com. So this prevents the seller from having my email address. Furthermore, the seller can now reply to this message, and the proxy will take care of forwarding it back to me, this time obfuscating the seller's email address. So let me just summarize this into some requirements to help drive our solution. The root requirement is to protect your customer's information, specifically their email addresses. We'll also want to allow compatibility with existing email clients and standards. The way that some businesses solve this type of problem is by forcing their customers into a website interface to send and receive messages. This is not ideal, as it took some members of my family years to figure out how to work email, so the last thing I want to do is teach them a new way to communicate. Additionally, we'll want to make sure that we're secure. We don't want to have this solution act as an open relay, allowing just anyone to contact your customers. We also want to ensure we have high availability so we can support robust and time-sensitive communication. And finally, you may even want to support the ability of saving a copy of every message sent between the two parties in the event that you need to audit a dispute. For example, the dispute that I'm having with the seller of my selfie toaster. So, on screen is a diagram depicting how this architecture may look before you move your email infrastructure to AWS. And so you'll likely have some receiving email servers that accept your message and potentially hand it off to some appliances that do spam and virus scanning. Then your main application will likely be communicating with your database layer where your customer information is stored. And finally, once your application is ready to forward the email along, it'll do so by passing it off to some email servers which handle the final delivery. So as you might imagine, we can start replacing some of these components with AWS services. We'll use SES for sending email and EC2 for hosting your application. We'll then maybe leverage one of the many AWS database offerings. And finally, we can replace all of the receiving email infrastructure with the new features of SES that Mahe introduced. One last thing I'll do is replace the EC2 instances with an Amazon Lambda function. This allows your application to run on demand whenever an email is received. So the foundation of this solution is an SES receipt rule. And this receipt rule is going to instruct SES what to do with email coming in. For this solution, we want SES to save a message to our S3 bucket and then invoke a Lambda function where your application logic will live. So I'd like to now show you how you can create a receipt rule in the AWS Management Console. All right, so from the main page of the SES Management Console, we're going to navigate down to the Rule Sets link. And this is the section of the console where you will manage all rules and rule sets associated with receiving email with SES. We're then going to want to view your active rule set, which is the rule set that's currently processing all emails coming into your account. We're going to create a new rule. And we're taken to the first step in this new rule wizard, which allows us to specify the recipients that we want this rule to match on. If we leave this blank, then this rule will match every single email coming into your account. We can also enter an email address or a domain. For this example, I'm going to enter a subdomain, mail.sesexample.com. We'll notice that this domain is not currently verified with SES. So we can click here to generate a quick DNS token, which we'll need to add to our domain's DNS in order to prove to SES that we do own this domain. We can do that at a later step, and I'm going to continue creating the rule. Next, we'll specify which actions we would like SES to perform once this rule matches an email. For this example, we want SES to start by saving the message to S3. We can specify a new S3 bucket and optionally, we can specify an object key prefix or a KMS key, which will be used to encrypt your message content before SES saves it to your bucket. Next, after SES saves our message, we're going to want to select the Lambda action. This will tell SES to invoke a Lambda function. I'm going to select an existing Lambda function, which I'll show you the contents of in a future slide. Next, we're going to leave the event invocation type selected. This is the invocation type that tells SES to not wait for your function to finish before processing the rest of the actions in your rule. This is in contrast to the request response invocation type, which tells SES to synchronously wait for your function to finish. I'll talk more about this type later. We can also select an SNS topic if we want to be notified each time one of these actions is run. Next, I'll name this rule something, and we'll want to ensure that spam and virus scanning is enabled. We'll be using the results of the spam and virus scanning SES does in the contents of our Lambda function. One other thing that I'll note, while not useful for this example, is the option to require TLS. This means that this rule will only apply to messages that come in over a secure connection. Next, we can select both the rule set that we want this rule to be inserted into and the position within that rule set. Finally, we can review everything we've done and hit Create Rule. Great, so what we've done is just create a new SES receipt rule, which instructs SES to write messages to an S3 bucket and invoke a Lambda function. Our Lambda function will then begin by reading the content from S3 and determining who the intended recipient of the message is. We'll then want to filter out any abuse, such as spam and viruses, and finally forward the message along using an SES send email API call. So I'd like to turn this diagram into code. So the following is a Lambda function written in Node.js. The first thing is the function header, and this is the entry point for every Lambda invocation. Within that function header is an event parameter. Now, this event contains information about the message SES received. We can use that, for example, to determine the results of spam and virus scanning, which in the first if statement, we're using to return early if a message is marked as spam or as containing a virus. By calling context.succeed in here, we're telling Lambda to suspend execution of this Lambda function because we don't want to process those messages. Next, we'll parse out the from and to addresses of the email from that same event object, and we'll then use the to address to parse out that order ID, which is the local part of the email address. We'll use the order ID to look up both the buyer and the seller email addresses involved with that transaction. And once we have the buyer and seller addresses, we can determine who the intended recipient of the message is. We'll do that by looking at the from address. If the from address is the buyer's email address, then we can assume the message is going to the seller, and vice versa. If the from address does not match either the buyer or the seller's, we'll log a message and return early, as this is not expected behavior. Finally, we'll get the message content from S3 and copy it into a new SES send raw email request. This time, however, we'll override the from address to be our obfuscated email address containing order ID, and we'll override the to address to be the intended recipient we determined in the previous step. Great, so really quickly I was able to show you how you could implement such a solution. I'd like to touch on some improvements that you may consider if you're thinking about implementing a solution like this on your own. One thing that's helpful for preventing abuse is to disable communication between the two parties after a duration of time. This is possible, for example, because it's unlikely that the buyer and seller will need to communicate say after 30 to 60 days from a date of sale. We can also leverage Lambda's integration with CloudWatch logs to save logs of each message passed between the buyer and the seller. Finally, we can also emit metrics to help track seller performance, such as time until first response or the number of unanswered emails. These could also be exposed to the seller to help them improve their processes. So how much can you expect to save by having a solution like this on SES? Well, we looked at customers who had similar solutions running on EC2 instances, and assuming you want the same level of availability, you'll have at least one EC2 instance in 3 different availability zones. This alone, with a load balancer, will cost anywhere from $150 to $600 a month. This does not include the costs associated with any software that does email receiving, sending, or scanning. With SES, all of this is included, and assuming 500,000 emails per month, this is going to run you $50 with SES. In addition to this cost savings, you'll notice a huge reduction in the time spent operating, configuring, and maintaining servers and software that receives and sends email. Additionally, you'll receive the benefit of being able to scale from hundreds to millions of email a day without any advanced planning. Great, so next I'd like to move on to a different solution that you might find a little more prevalent than the last. So on screen, I have 4 different excerpts of emails I've received in the last month. And I've circled in orange the unsubscribe links. And I'm sure everyone's familiar with this minor annoyance of having to find the link at the bottom of the email and occasionally having to jump out to a web browser just to finish unsubscribing. Well, I'm happy to say that there is a good solution to make this problem a little bit easier. And that solution is the list unsubscribe header. By simply adding a header to all outgoing email, you can help enable clients the ability to display a really nice unsubscribe link, like the one Gmail is displaying here. And this is really great news for both email senders and those of us who receive their email. The list unsubscribe header has actually been around for over 15 years. However, it's more recently gained popularity with email senders and those of us, and those clients that display email. The way that it works is by including this email address in the header. You're enabling the client the ability to submit an unsubscribe request on the recipient's behalf. Now, these unsubscribe requests still need to be processed by you. So you need to have some email architecture set up to receive these unsubscribe requests and remove customers from your mailing list. So that's the focus of the next few slides, is that architecture. To summarize, we want to add this new header to outgoing email and set up a system using SES to receive the messages and update our mailing lists. Similar to the first example, we'll want to ensure that we're secure and fault tolerant so that we don't miss any unsubscribe requests. So let's take a closer look at the header that you need to add. Within the email address is a unique identifier, which allows you to identify which customer wants to unsubscribe. Now, it's important that this is somewhat opaque so that malicious users cannot simply unsubscribe anyone they would like. You may also want to contain a campaign ID in this identifier, which enables you to have per campaign unsubscribe metrics, which can be quite useful. One other thing I will note is that HTTP URLs are also allowed in this header. This will allow you to provide a website that you want users to unsubscribe through. However, for this example, I'll be focusing on the email-based approach. So similar to last time, an SES receipt rule is going to be created to instruct SES what to do with these incoming unsubscribe requests. However, unlike last time, we do not need SES to save the message content to an S3 bucket. And this is because this event object that's handed to every Lambda function invocation contains enough information about the message received that we don't need the full body of the message. So this is pretty great, as it allows us to skip the costs associated with reading and writing to S3. So let me show you what this event looks like. Each invocation of a Lambda function will contain an object similar to the JSON displayed on screen. The first parameter is a mail object, which contains information about the message SES received, such as a list of commonly used headers. This is where you'll find things like the to and from addresses or the subject line. Next, there'll be a complete list of headers, which is where you'll find a DKIM signature if present. And finally, the SES message ID, which is the identifier that SES assigns to the message. This is also the key you'll use to retrieve the full message content from S3. Finally, there's a receipt object, which contains information provided by SES about the email, such as the results of spam and virus scanning, and whether or not the email had a valid DKIM signature or passed SPF. So this is really nice, as it allows your application to act on the results of these things without having to re-implement the algorithms required to check DKIM, for example. So let's continue looking at the contents of this Lambda function. We're going to parse out the recipient and use that identifier to look up which customer wishes to unsubscribe. We'll then filter out any abuse and finally unsubscribe by removing that customer from our list or updating his subscriber preferences. So I went through that solution a little bit more quickly. I'm not going to show you the code or how to create the rule. There was enough in common with the first one. However, I would like to show you how we can build on top of the two previous solutions and extract a common component to make them a little bit less complex. So what's in common between these two solutions? A big one is the fact that they both need to do some sort of abuse filtering. And this can mean many different things. Most commonly, it means you don't want spam and you don't want viruses. However, it can be more than that. It can mean that you only want to accept authenticated email, email that passes SPF and DKIM. Or even further, you may want to do an external request to decide whether or not you want to accept the email, such as looking up a user in your company's directory to determine if the recipient of a message is a valid email at your business. So all of these are different types of criteria that you can use to decide whether or not you want to accept a message. So to take a step back, this is the two rules that we've created so far within our active rule set. We have our anonymous email solution, which is a rule that matches all messages to mail.sesexample.com. And then we have our unsubscribe solution, which is a rule that matches emails to the unsubscribe subdomain. Next, I'd like to add a filter before both of those, which will apply to all recipients or every message that comes into this account. And this is possible because SES rules are ordered. So if we put this rule before the other two, we can ensure that it runs first. Let's take a closer look at what's in this rule. The heart of it is a Lambda action. Now, the purpose of this Lambda action is to determine whether or not you want to accept the message, whether or not the email is desirable. This can be looking at any of the criteria that I previously mentioned, such as, is the message spam? Now, if the message is not desirable, we're going to want to reject it using the SES bounce action. This is an action provided by SES that makes it really easy to send a bounce message back to the original sender of a message. This way, the sender knows that we did not accept his message. We'll then use the SES stop action, which is another action provided by SES, which tells SES to not process any other rules in this rule set. This way, after we've rejected a message, our other two rules below containing our applications do not process that undesirable message. So let's take a closer look at that Lambda action to determine how exactly it's working. This Lambda action is using that request response type that I mentioned previously. This means that SES is going to synchronously wait for our function to return and inspect the return value of our function to determine a specific action. So, for example, if the message is not desired, like if it's spam, our Lambda function is going to return continue. This tells SES to continue processing actions in that rule. This way, our bounce and stop actions will run, rejecting the message. However, if we do want to accept the message, we'll return stop rule. This tells SES to stop processing any other actions in that rule. This way, our bounce and stop actions do not run, and we continue processing the other rules in this rule set containing our anonymous email and our unsubscribe applications. So this is really neat, as it allows Lambda functions to help control whether or not you want to accept the message. One other thing that might be useful is to save a copy of every message before you reject it. This will help provide insight and visibility, and we can do so easily by adding the S3 action between the Lambda and bounce actions. So in summary, we've created 3 rules today. We have our abuse filter, which matches every email coming into this account. And if a message makes it past the filter, we then have 2 rules, the anonymous email solution and the list unsubscribe solution. So you can imagine having many, many more rules in order to process every use case for receiving email at your business. You can even have layers of filters that help control email at different points in your rule set. So with that, we're really excited to see what you will come up with leveraging the SES receipt rule system with Amazon Lambda and the other actions provided by SES. So we're excited to see what ideas and feature requests you'll come up with, so please consider sharing them with us on the AWS forums, or check out the SES blog at sesblog.amazon.com, where we share feature announcements and tips on how to use the SES platform. Thank you so much for coming. I hope you enjoyed this session. We'll be outside afterwards taking questions if you have any, and enjoy the rest of your reInvent. Also, please leave us feedback, as that's super important to us. Thank you.